Welcome. This is the English language translation of the Open Sensordata talk by Felix Erdmann, live from the 36th Chaos Computer Congress in Leipzig. All talks at Congress are live translated between German and English and to one additional language. Visit c3lingo.org for more details and information on how to access the streams. We appreciate your feedback. Please use the hashtag C3T. Your translators for these talks are Kvi, VH1 and Pete Priority. So please a round of applause for Felix Erdmann.
Hello together, thank you for coming and thank you for this introduction. This nearly covers my whole first slide. I'll be talking about open sensor data for everybody, based on open source, open hardware and educational resources. It's an open senseBox project by the University of Münster. And we started this a few years ago with small Arduino kits and went into the citizen science project field. And first, I would like to tell you something about myself. My name is Felix Erdmann. In 2012, I was a student intern at the Institute for Geology Information Science, and I had first contact with sensor data and Arduino and different kinds of sensors, environment sensors, environment data, and I put this small module on a drone, and that was basically my first point when I started with this field. After graduating from high school, I studied this field and graduated from university, and now I'm a teaching assistant at the senseBox project at the university. What is senseBox? Who has heard of that? A few. senseBox is a DIY toolkit for stationary and mobile sensor stations based on open hardware, especially on the Arduino platform. And we got different versions of the senseBox that we developed, and we distribute them to cover different fields and areas so that every citizen can become a scientist. And the other field is digital education. We want to connect with institutes of education, high schools, and we want to show students that coding is not as difficult as it sounds. And we want to establish a certain understanding of coding. The other product is the openSenseMap, which is a web-based platform on opensense.org, where everybody can register his or her sensor station and look at the data collected there. We have different tools there to visualize data. So one field is citizen science, and everybody can become a scientist and participate in science. There are different levels for that. The lowest level is for users to simply gather data, up to the highest level, which means that the user not just gathers data but also interprets data and can publish scientific findings. And this is why we developed the senseBox Home. This here is in Sao Paulo. It's a plug-and-play sensor station. You do not have to assemble a lot. Just plug it in with a USB port, and you can gather environment data with this. They can be transmitted via Wi-Fi or other means.
Gibt es dann das Äquivalent für die digitale Bildung, das nennt sich die senseBox Edu.
Other equivalent for education is senseBox Edu. We have a microcontroller here
und dazu noch verschiedene Sensoren.
and different sensors.
Temperatur, Luftfeuchtigkeit, Luftdruck.
Usually it's temperature, humidity,
Zusatzoptionen kann man auch noch
pressure.
den Feinstaub messen mit einem SCS-Sensor. Kennen vielleicht einige.
And
was ich da
you could also measure particles in the air.
Die senseBox Home eher so Plug and Play, also man muss alles.
It's also plug and play.
Bei der senseBox Edu ist es ein bisschen anders. Da muss man, also kann man auch einfach alles zusammenstecken. Da sind aber noch ein paar mehr Komponenten drin. Da haben
But
wir noch
here there are
LEDs,
a few more components,
Drehregler, Buttons, ein
few
Display.
buttons,
Das kann man
display,
alles manuell anschließen
and you
und dann
can
verschiedene
connect that manually
Projekte ermöglichen und
and enable different projects.
die Box an sich programmieren.
And then you can
Dazu
program
haben
this
wir
box.
Dieses Programmiertool von Google genommen. Das
We
nennt sich
created,
Loki.
we
Da
used
kann man,
Google's
ja, wie
programming
Scratch,
tool.
einfach Puzzleteile
Like in
zusammenziehen,
Scratch,
kann da,
you put
verschiedene
together
Werte
different
eingeben und anhand
pieces,
dieser Puzzle-Oberfläche kann man dann seinen Quellcode ziemlich einfach
and
zusammenstellen.
with this interface you can easily assemble your own code.
Für die jüngeren Schüler gedacht, die halt
It's meant for younger students who do not have any experience with coding.
Den ersten Quellcode zusammenschreiben. Für die etwas erfahrenen Schülerinnen und Schüler,
The more experienced students
auch den Quellcode an sich
can
selber
then
schreiben, wie wir das hier auf der rechten Seite sehen.
just enter code like we see on the red side
All das
here.
basiert, wie ich schon gesagt habe, auf Open Hardware.
All this is based, like I said before, on open hardware. We've developed our own module based on Arduino. It's the senseBox MCU, and the reason why we've done that is because we are using Arduino Uno, which we started on, that you couldn't use all sensors at the same time, and you can upload the code. The memory capacity wasn't high enough, so therefore we added this module and modified it. We have different ports, I2C, analog, digital, and serial ports. And they have plugs which you can only plug in one way so that you can't get a short circuit with the sensors. So it's rather easy to build your own sensor station. It has two EXP ports, which you can transfer data from, be it via Wi-Fi, via LoRa, or over an SD module where they are saved. So you can do it offline and connect them with a data card, and then have a look at them at home. All the circuit layouts, the Gabber files and libraries, they're open, they're all available on GitHub, so everybody who has the means of building it, they can solder and assemble it themselves. As I said before, the openSenseMap is the backbone of the project, so everybody can register their own box, gets sent the source code, and then can upload their measure data. As you can see here, on the whole world, we are distributed. Of course, in Germany and in Europe, there's the most, but there are on even crazier locations, there are boxes which send their data onto this platform and the way you can view them from. In addition, there is a small analysis for the data. On the map, when you click on a station, you can see details, you can see information, and you can diagrams from data. For example, somebody uploads a picture, you can see the temperature on the temperature curve of this box. As I said before, this is all open here, so the openSenseMap, not just SenseBoxes can send their data there, but everybody can. So if you've got something else, or if you have a Raspberry Pi or an ISP, you can send it onto this platform. We have an open API with REST, so it can accept all kinds of data. Some examples are the a SenseBox where it can measure the water flow and distribution direction of the flood. You can measure air data rather easily and send it into this platform. Then there are sort of more unusual ones which are being built in the garden, which measure wind direction and speed. Smart citizen devices can also send that, and obviously the SenseBox, and even self-built stations and systems. And then we are not limiting this to certain phenomena, but you can measure Lord's temperature, air humidity, sound, all sorts of gases. As long as you can measure it, you can upload it. So the source code is freely available on GitHub, which is the sketch, the code that's on the Arduino, the SenseBox MPU, the front end, the back end, all the API and the services which we developed. You can download them and look at the source code. The website and the teaching materials. This is all available on GitHub, and the API is also open, so everybody can upload their data. So these are all educational resources. They are available for teachers and institutions, because the hurdle to get into using the SenseBox can be quite large. So many people don't know how to use it, don't have the time to get used to it, and we want to lower the hurdles of entry for digital education. So I wanted easier to develop projects that you can move along. So theory and practice, for example, it's here a traffic counter with an ultrasonic distance counter, which you can use to measure distances. And in this example, it shows you theory on how to check the access and how to connect the sensor, what you can do with the data. One example that was used in school, and then the students, they could check the amount of traffic in front of the school, and then they really measured how many cars were driving past the school in about a quarter an hour, and then we could really put facts onto the problem. So when we say there's too much traffic but nobody really knows, in this case we can rather easily get the data and then analyze what we can change. Just a little bit on the timeline. So for me personally, the project started in 2012 when I was a pupil doing some volunteering at the university, and then the first models were used in teaching, all based on Arduino in all sorts of combinations with devices, and I put this kit on a drone, flew it around. The real start was 2016. We got a support from the grant from the German Ministry of Education, and we got all sorts of results on what ends for the openSenseMap, for all sorts of modules that you could interpolate data, to estimate it between different data, so temperature, for example, from the hardware. We did a 3D printer to build cases to ensure the sun wouldn't go into the sensors that easily. We tested under extreme conditions in Swiss mountains with super cold temperatures or lots of snow. And that was a project for testing. That's what finished. And then we have a it's called SenseBox Pro, which just got funding also from the German Educational Ministry, also for 3 years. And we want to use professional users and use really high cost sensors. Right now it's just low cost. The sensors are good and nice, but the real professional users can't really do something with them. So we can use different sensors and check with the industry if the industry is interested in this.
On the software side, on the openSenseMap, you can see different analysis methods, so you better compare the data. We asked ourselves at some point, it's a citizen science project, so open science, it's called open science, and we want the data to be reproducible. But we asked ourselves, who really participates here? Because we say everyone can participate, everyone can take over different tasks, but what kind of people are there? So in a master's thesis, we did a survey and try to figure out who are the participants. It's mostly men, so who would have thought? And the age is between 30 and 55 is the highest portion. What's interesting is that a lot of participants have academic backgrounds. They have a bachelor, master, or a diploma. And from this area, there's a lot of participants. We rather thought that everyone can participate, but apparently a lot of people are not interested in, or maybe the hurdles are too large. But it's mostly academics that participate in this project. For some background, so the users we asked are all users that are registered on openSenseMap. So all the users that registered their station once and uploaded some data. And it's not people who just download the data, and we couldn't get the data of these people. So what's the motivation of the participants to participate here? So we can say more or less that everyone likes to measure environment data and collect them and publish them. So they don't just want them to themselves, but they want to share them and maybe even influence political decisions. In the area of communication, we want to support the community, or one wants to support the community, one wants to help in order to solve certain problems. One wants to maybe even encourage other people to participate, but really to meet other people, that wasn't a big part or a goal for these participants. A lot of the people thought that more should be done with the data, like a bigger analysis. But to participate in the scientific process themselves, or to write even a publication, people didn't really want to do that. And you can also see this from the main usage of openSenseMap. Most people just want to share their data, to measure the data, and just to participate, to contribute. But in the end, they just look at the data, create diagrams, and add sensors, play with the boxes. An analysis of the data through interpolation, for example, has a very low priority and is not used a lot. We collect quite a big amount of data, so we're already in the big data area. We have about 5,700 registered boxes, 5 to 6,000 measurements per minute, and we have about 3.9 billion saved measurements. Everyone can download all the data by themselves and work with it. It's not really a problem, because you only save the raw data, not the validation of data, in order to get the data that the users really measure. On the whole project, especially in the infrastructure, we have some problems. We have quite hungry servers. They're running in the cloud on AWS, but it's going to be moved to the OpenStack at the University of Münster. They require quite a lot of memory and hard drive space. The database is MongoDB with 4 collections. And there we have the problem that since it's really a huge database, the indexing and the request of statistics takes a long time, because the whole table has to be parsed in order to grasp the data and to compute statistics. And that's basically one reason, because we kept the original architecture that originated from a bachelor thesis. So we started with a prototype and it just grew and grew. More and more data came in, and now we have this 3.9 billion data points. And now we have to start thinking about about a more efficient way to store this. As said, we only save the raw data, so we don't really modify the data, and the data is also not validated. So from this, other problems originate if you want to analyze the data. So this is a screenshot from this morning from the interpolation here in Leipzig. You can see the temperature, the calculated temperature between different boxes. I chose only boxes that are set up outside, and we can see that everything is nice and green. But in the top right, there's a box that's orange-red, and that means it's more than 20.7 degrees Celsius. And I thought this can't be quite right. A box that's outside and measures 20 degrees Celsius. And I looked a little bit more closer, and it turns out that's constantly around 20 degrees. So you can deduce from that it's probably inside, and so we can't really do the interpolation here because this falsifies the measurement. On the other side here in Hamburg, this is another screenshot. There's a sensor broken in the middle, somewhere in Hamburg, constantly measuring about minus 150 degrees Celsius. So this interpolation here also doesn't really work. And that's another goal that is supposed to come in the future, to detect these kind of exceptional data points and to take them out of the data set that you want to analyze. So in the future, the development is done by the RE-EDU Corporation and the university, and at the university, within the support of the BMBF project. So more materials will be added, more projects for the educational area. The hardware and software will also continue to be improved. We're trying to add new sensors and add a Wikipedia for all the sensors to have a uniform system. And you get a summary what kind of sensors there are and what kind of deviations can come from this. So the sensors one of the sensors we are using, for example, is very affected by humidity. So it's just things to keep in mind when you look at your data. Our goal is that this project is mostly community-driven. So the further development of the software happens on open source basis. So everyone can participate if they want to. And this under the umbrella of a common company and independent support. So we started a Discord forum where everyone can register and can exchange ideas with each other and answer the questions.